On the screen, we put there up there what you would see on SEALCOIN platform. Okay, and we divided the screen in two parts: the platform and the device A on one side, the platform and the device B on the right side, and below the DLT network, Hedera's activity. Okay? I want to drive your attention to the two different wallets. You will see that as we are two different owners, we need to have different wallets and they have their own addresses. You can see that through the platform onboarding, we have one active device and one active certificate, and 0 services sold or purchased yet. The proof of concept, okay, that we put together is to enable two devices, A and B, to transact together. What we want to achieve is that A is interested to purchase the data from B. Okay. They are equipped with certificates, the device is registered, and they all each have a wallet with SEALCOIN in it. Okay, that's the beginning of it. With that, the first action to do is to create a communication layer for which we are using the certificates to have a secured layer of communication between each of them.
So each device has its own certificate, and this is why the connection will be secure.
Exactly.
Chris, then you can start the device B. So now device B is listening for connection, and I will start device A. And thanks to the platform, device A will know the IP address to which to connect. Okay, so now the connection is established and secure.
So now what you see on the screens, on the two different screens, is a connection which has been established between those two devices.
Yeah, you should mention that for making this connection possible and to make it secure, we have been using in both devices a Vault IC preloaded with a certificate.
Yes. This
Yeah,
is
there is a Vault IC
in
each one.
Yes. The hypothesis that we're taking is that the platform is up and running. The devices use Vault IC for 8, and the certificate has been loaded into the devices.
Yeah, you mean the Raspberry Pi?
The two Raspberry Pi.
They both have Vault IC.
Right.
Yes.
What you can see here is the Vault IC.
Okay. Next step, once the communication has been established between the two devices, what we want to ask, the device A will ask if the data is available in device B. So
yeah,
Jeremy is entering his data available.
My Raspberry Pi say it received the is data available message, and it responds. And I received the answer: data is available for 10 SEALCOINs to be sent to.
Can you blow this window? We only see the very small window there. Do you mind to blow that? Make it bigger?
You can.
You just yeah. Yeah, great.
Is it better now?
Yeah.
So I'm explaining what's happening here on the presentation. The device A asks the device B if it has a specific data, and device B not only answered, yes, I do have the data, but provided the price, 10 SEALCOIN, and provided its own wallet ID to be paid there.
Yes.
Once we have this confirmation, the device A, before entering into a transaction, will check his own balance. Okay? And remember, we're using a decentralized ledger. So this is public information. The device A will ask Hedera to verify the balance, and Hedera will tell him you have 1,000 SEALCOIN. We can all see it, but the device cannot see it into the platform.
Yes.
So device A sent the transaction, the request, and got confirmation of the 1,000 SEALCOINs available. Once we have that, the device A will do a couple of things. First of all, it can accept the price or refuse this price and say 10 SEALCOIN is way too high. I don't want to buy, and no transaction. Okay. Let's assume we say 10 SEALCOIN is good. I want to buy this data for this price. And the other critical element is that the price of this transaction, 10 SEALCOIN, is lower than my balance. I can afford it. If those two elements are validated, the device A will create a transaction and sign a transaction. So
yeah. So here I know that there is enough tokens to create transaction. So I will request data.
Maybe before you send the request, to show the data we want to exchange, it's just a temperature 15 degrees.
So here, what Kristen just showed is the data which is available inside the device B, which is temperature equal 15 degrees. Okay, that's the data we want to sell to device A, which do not exist yet in the device A. If you go into the files and the folders of the device A, there's no data at all. Okay.
Yeah. I request.
So that could be a thermostat, that could be any device that needs to check the temperature
Exactly.
of the device. Yeah.
Exactly. For now, it's a temperature, but that could be any type of data.
Yeah, exactly. Exactly.
Once we have that,
so here is a manual way to do it just for the demo. So I enter the recipient wallet ID. I enter
me.
Yeah.
Yep.
The wallet ID of the device B. I enter the price. And then here I created a transaction. The transaction has been signed with the Vault IC. And this signed transaction has been sent to device B.
Why do you sign it 5 times?
Sorry?
Why do you sign it 5 times?
It's in the EDERA process. It's in the and here on my side, you can see I've received the 10 SEALCOINs and the transaction is a success.
So what happened here is that the device A sent the signed transaction to device B.
And then I can see the data here on my file system.
It
now.
worked. Wait, because what we're doing now is that we're decomposing the steps of this PoC. We'll do an automated version right after. Don't worry. So you'll see that it's all automated. But now we're decomposing to explain all the steps to everyone.
Yeah.
Once the device B receives the transaction, it does 3 things. It first checks that those are SEALCOIN tokens. It can only work with SEALCOIN token. It checks the price. I asked for 10 SEALCOIN. There is 10 SEALCOIN in the transaction. And it checks the ID. That's my wallet ID. That's okay. If I have everything as a device B, I send this transaction to EDERA. EDERA, being the public ledger, is executing the transaction and creating a receipt and updating the status for everyone.
Where do you send it to EDERA? What is EDERA?
EDERA is a decentralized ledger.
No, it's not.
It's the one that does the validation of the identity. That's
It's an IP address.
It's an
Yes.
IP. It is centralized.
EDERA is composed of several nodes which form a network, and you can contact one of these nodes thanks to its IP address.
So you need
yes.
all necessary IP addresses somewhere in the
At least one.
So it is hard coded in the device.
No, the EDERA SDK is doing it for us.
Okay,
It's looking for available nodes
I see.
and send the transaction.
Okay,
But
so
we
there is
can-
a sort of agent in the device. At
This
the
is an interesting thing that we can specify the node on which sends the transaction. Okay.
Yes.
This is
There
where
will be many things that we can do with these nodes,
we have a problem.
but I don't want to confuse the proof of concept. Now that Hedera executed the transaction, what it does is that it's sending the transaction receipt to device B. And because this transaction is executed and it's a public ledger, we can all go into a public ledger to check this transaction status. Okay, it's available to everyone. We'll do that right after. Okay. Once as B, I receive the receipt, I can validate that I received the receipt, and therefore I can send the data. What happened in parallel are the wallets. If you see closely on the presentation, you see that the wallet of device A was updated to 990 SEALCOIN, paying 10 to the wallet address B that has now an update. And you have here my services. I purchased 10 services, and here I sold 10 SEALCOIN for services. With that, the device A is validating, and as you can see on the screen, that it received the temperature you wanted to buy. Okay, we decomposed all the steps. We're gonna do a new transaction now, fully automated, and instead of looking at the devices, we're gonna be looking at the hash graph scan, which is again public information. So here, what we're doing is that we're connected to internet, to this address, and this is the wallet address of device A, and this is the wallet address of device B. By the way, before we started the PoC, the device balances were each 1,000. You can see that here, the balance are already updated.
Yep.
And you can actually see the detail of the transaction that happened. Need to refresh that. At 11:21 today, where we sent from this wallet address 10 SEALCOIN to this wallet address. It has been printed, it's on internet. I don't control this database. Hedera is not controlling this database. The device is not controlling the database. This is a test net. This is a test net Hedera, but duplicating the real one.
This is really Hedera
Yes.
was
Really decentralized.
It is fully decentralized way that we have executed it. It's not in production mode. It's a testnet environment that Hedera is providing to people to test things like that.
And the good thing there, now you have a non-repudiation transaction. It cannot be repudiated. This transaction has happened.
It's immutable.
Immutable, exactly. And that's what makes this so special, you know, because it basically records a TIoT transaction between two devices in a way that is non-reputable.
So now what we're going to do is that we're going to execute the transaction all the way through, fully automated from device A to B. And you will see what happens.
What I have done is that I changed the temperature to 20 degrees to show it will change on the other gas.
Yeah. For the moment, I have 15 degrees, and after the transaction, it will change. So I request get data. This is an automatic way, so it will do all the steps.
all same thing, but you know
All the steps fully automated. So if you execute them,
Here we can see.
here we go, 11:28, it's already printed on the blockchain. So here
Wow.
we see that the device A sent 10 new SEALCOIN at 11:28 to device B. Device B received them, and the new balance of device A is 980. New balance of device B is 120. And what we can check on the screen of the device A is that it indeed received the data, which is temperature equal 20 degrees now.
Very good. Congratulations, guys. This is amazing.
Well done. It is,
Sí, allez, on applaudit tout le monde.
absolutely.
So we can finally prove that
Historical moment.
this proof of concept actually works. And we can move on to the next steps of delivering such a platform to be able to issue the token when we go live with the platform and start onboarding partners that will want to see transactional IoT as a reality.
Amazing. Ça, c'est un vrai flou, hein.
What we have done here is what IOTA tried to do for a long
Yeah,
time and
everybody.
raised
Yeah.
billions.
$billions, and they failed. IOTA failed miserably because they only look into the. It's like Matter. This guy is only looking about the certification, but they are not technology players. They never go deep dive into how that certification can be immutable and non-reputable. That's the key point here.
The key element here is that we had the building blocks to move on.
Imagine this for Lance and Gear, you know, to be able to extract the electricity consumption of the smart meters from one device to another. Because, for instance, I want to buy the credit one device has on another with my solar panel. I mean, this is the kind of use cases that they are possible now.
And these are actually the use cases that we want to tackle now, that we are starting to discuss with potential clients, where if the PoC is proving that we can exchange data, this data can be also replaced by energy.
Yes.
And we can ask the device to free the amount of energy required into the transaction and pay for it remotely.
Yes. Is Jean-Pierre there with you guys?